All right, question 1a. We have two binomials being multiplied together, so we can either do FOIL or we can do the box method. Let's start with the box method. Build a box. These each have two terms, so I'm going to give two terms on the top and two terms on the bottom. Start filling it out. And we're going to fill everything in. X times x is x squared to the power of 2. 6 times x is 6x. Negative 6 times x, negative 6x. Now negative 6 times positive 6 gives me negative 36. Now that we have everything in the box, we're going to put it in a very long addition problem. So we've got x squared plus 6x minus 6x minus 36. These two terms are exactly the same, but one's a positive and one's a negative. That means they're going to cancel each other out. And I'm left behind with just x squared minus 36. That's my final answer for that one. Okay, let's do the next one. Whenever you have something that says to the power of 2, all that means is to write it twice. So let's write out this in parentheses 2 times. X minus 3, x minus 3. Let's do FOIL this time. X times x gives me x squared. X times negative 3, negative 3x. Then we're going to do the insides. Negative 3 times x is another negative 3x. Negative 3 times negative 3 is positive 9. Looking for what we can combine, I have a negative 3x and a negative 3x. When I rewrite that, it's going to look like x squared minus 6x, because that's what a negative 3 and a negative 3 together is, and you add 9. There's your answer. I'm going to solve this one a very similar way, but the first thing I'm going to do is distribute this 2 into everything on the inside first. So 2 times x, 2 times negative 1 gives me 2x minus 2. There's my binomial. Bring down your other binomial. And we're going to multiply either by the box method or the FOIL, whichever one you prefer. I'm going to go ahead and do box method. Cool. Now that it's all filled out, remember that on the diagonal is where the items combine. It's like we're going to add those together. So 8x and negative 2x gives me a 6x. Then I bring everything else out. So I got the 2x squared minus 8. And I'm done. I'm going to come back to D and C. Let's just do this one really quick. I'm going to do it with FOIL really, really fast. All right, let's go back and do D. Yes, they have parentheses around them, but that doesn't necessarily mean I'm going to FOIL or do the box method. We only FOIL or box method when it is being multiplied. So like there's an invisible multiplication symbol in the middle there. But this one doesn't have that. It has an addition sign. So that tells me I'm going to combine like terms. 2x and a 4x become 6x. Positive 6 and negative 7 become a negative 1. So I'm not foiling for this one because it's just addition. You only FOIL and you only do the box method if it's multiplying. Okay, let's do the next one. I'm going to distribute this 1/3 into everything. 1/3 of 9 is 3, so 3x. 1/3 of 6 is 2. And just because we have parentheses again, don't mistakenly do FOIL or the box. We are subtracting. 3x take away x, 2x. 2 take away 2, that's 0. You don't need to write the 0, so your answer is just 2x. And that's that. Okay, number 2. A particular algebra text has a total of 132 pages. So there's our total amount, which is broken into 2 parts. We have a part 1 and a part 2. The second part of the book has 64 more pages than the first part. How many pages are in each part of the book? Well, I'm not going to write out the first part and the second part, so let's come up with some variables to represent that. Let's call x our first part, and we will call y the second part. We know that x and y together is this much. So let's write an equation saying that x plus y together has 1,382 pages. Then it gave us some information about the second book. So my second book, or y, we now have an equation for that. Y, or the second part of the book, has 64 more pages than the first part. So that means you're going to take the first part and we're going to add 64 to it because it's 64 more pages. Now we're looking good because this is a system of equations. So we can solve systems that have multiple variables. We're going to look for either elimination, substitution, or graphing. I don't have a graph, so I'm going to go for elimination or substitution. You want to look and see if there's any variables that are isolated. For example, I see that this y is all by itself. Y is equal to all of this right here. I can take that value and substitute it in for y, and then I can solve for x. Let's do that. X plus something gives me 1,382. So we're going to plug in that amount. X plus 64. We are taking what y was and replacing it with what y is equal to. And we are going to solve for x. X plus x is 2x plus 64 equals 1,382. I'm going to minus 64 on each side. It's supposed to be a 4. When we subtract that out, we get, not sure, let me do some scratch work. Can't take 4 from 2, so I go to the neighbor and borrow some. 12 minus 4 is 8. 7 minus 6 is 1. And that 3 comes straight down, the 1 comes straight down. So I got 1,318. I'm going to divide that by 2. I know that half of 1,000 is 500. I know that half of 300 is 150, and half of 18 is 9. So my answer is whatever that whole amount is grouped together. So x equals 659. The first part of the book has 659 pages. But we're not done. Don't go run out that door. We're going to plug this into our equation and figure out what y is. Y equals, plug it in for x, 659 plus 64. So we're going to add those two numbers together, do some scratch work if you need it. 9 plus 4 is 13, carry the 1. 5 plus 6 is 11, plus that extra 1 puts us at 12. 6 plus 1 is 7, so y equals 723. All right. We got another system. We don't have any isolated variables and we don't have any graphs, so maybe I should do elimination. I can make one of the equations variables look like the other one with an opposite sign. These are both positive. This one's positive, this one's negative, and there's a 1 right here. If I can make that 1 look like a 2, I can make my y's disappear. I can do that by multiplying this entire equation by 2. So this would become 12x minus 2y, equals negative 20. And I'm not going to change this other equation at all. Watch this. When I add straight down, this positive 2y and this negative 2y are going to disappear on me, and I'm just going to get 15x equals negative 15. Divide by 15 on both sides. I got x equals negative 1. Don't go running out the door. We got to do something with that. Pick your favorite equation. It does not matter which one you pick. I'll pick this bottom one. 6 times x minus y equals negative 10. I'm going to plug in that negative 1. Negative 6 minus y equals negative 10. Add 6 on both sides. Now I'm not done. There's an invisible negative 1 there. I got to divide by negative 1. And now I'm done. You should write your answer as a coordinate, negative 1 comma 4, and then you're done. Determine if the following functions are linear, exponential, or quadratic, and justify how you know. So looking at this first one, looking for a pattern as it grows, it looks like it is multiplying by 3 each time. This one, I don't notice it right away. This one is decreasing by 2 every time. Since this one wasn't obvious, it probably means it's quadratic, but let's double check. I'm going to build my first and second differences. And see if we have a common or a constant second difference. To get to negative 8 from negative 5, it's getting smaller, so it is decreasing by 3. From negative 8 to 9, it is decreasing by 1. And then it starts to go back. It's going to increase now by 1, increase by 3. There's no constant pattern yet, so let's look for our second difference. Not going to use these two boxes. From a negative 3 to a negative 1, that is increasing by 2. From a negative 1 to a positive 1, increasing by 2. And it looks like it's constant. So compared to these three functions, this one has a constant ratio. This one had a constant rate. Of change. This one didn't have either of those, so constant rate or ratio of change, but this one had a constant second difference. This one's going to be linear because it is adding or subtracting every time. This one is exponential because exponential is always going to be multiplying every time. This one is quadratic because that's second difference. Okay, let's do our equations. The first equation, we're going to use the tried and true. Y equals BMX, where B is our y-intercept. This one we're going to use our y equals ax squared plus bx plus c. And this one's going to be our y equals mx plus b. Let's start with these two because they're a little bit quicker. Both of these require a y-intercept, and the y-intercept is wherever the input is 0. So I'm going to do it in green here and here. For good measure, let's do it for this one too. My b value for this one is 18, so I would write 18. My ratio of change is multiplying by 3 every time to the power of x. And we're done. This one is y equals negative 2x, because that's our m. We're going down by 2 each time. And our b value is plus 2, or a positive 2. This one requires a little bit more work, so we're going to need some scratch paper. I'm just going to use a sticky note for now. We need to identify our a, b, c, and an x and a y. Our a value is our second difference divided by 2. So we're going to use that 2 divided by 2, and we get 1. So a value is 1. B, I don't know yet. I have to figure that out. Our c value is our y-intercept, and our y-intercept is negative 9. For our x, we can pick any coordinate we want. Maybe I pick this 1, negative 8. Make our x 1, our y a negative 8. And I challenge you to pick a different coordinate, see if you get the same answer as me. Our y, negative 8. Our a, 1. Our x, 1 squared, plus b, we don't know what b is. We're going to plug 1 in for x, and we're going to plug in our c value, which is a negative 9. I don't need that plus minus 9. Maybe I should rewrite that. Negative 8 equals 1 squared times 1 is just 1. B times 1 is just b. Plus a negative 9 is like minus 9. 1 plus negative 9, or 1 take away 9, is negative 8. I'm going to add 8 on both sides to get b by itself. Negative 8 plus 8 is 0. So I don't have a b value. My b value is just 0. Let's plug everything in. Y equals 1x squared plus 0x, and my c was minus 9. I don't need to write that 1. I don't need to write the 0x. So my final answer is y equals x squared take away 9, and you're done. You can always test it by plugging in a value. We can do this real quick. If I plug in 2, let's see if we get negative 5. 2 squared is 4. 4 minus 9, yep, that's negative 5. So I did it correctly. Determine if the following functions are linear, exponential, quadratic, and justify how you know. Okay, so if we ever see an exponent of 2, that tells you it is going to be quadratic. And they want us to graph it. Let's build a table. I'm going to plug these values into my equation and see what it spits out for my outputs. So I'm just going to do this real quick. Okay, there's my pattern. It looks like it's going away from that 0. 0, 1, 4, 9, 0, 1, 4. If I were to do a 4 at the end, I bet it would spit out 9. And you can always test that. 4 minus 1 is 3. 3 squared, yep, that's 9. So there's my pattern. Let's put it on the graph. My highest y value looks like it's going to be a 9. So I want to make sure I build it where it's at least going to hit 9 up there. So I'm going to count down. 9, 8, 7, 6, 5, 4, 3, 2, 1. There's going to be my 0. negative 2, it hits 9. Negative 1 goes to 4. At 0 goes to 1. 1 to 0. 2 back to 1. 3 back to 4. And then if I were to plug in 4, it would have spit out 9. We already determined that. So there is my beautiful parabola. And it's good to go. All right, part B. I think it might be a J-curve, which would make it exponential, but let me double check. My first point, this looks like it's at 0, 1. My next point looks like it's at 1, 2, 2, 4. So I've got 0, 1, 1, 2, 2, 4. 3 looks like it's at 8. That little point there. See if you notice a pattern. To me, it looks like it's multiplying by 2 every time. So that means not only is there a J-curve, but there's a ratio of change. So this is exponential. The equation, we're going to use that y equals b times m to the x power. So it's going to have our y-intercept, which is right here. Y equals 1 times 2 to the x. If you didn't put the 1 there and instead you just said y equals 2 to the x power, that would have also been correct. Just like in part A, it looks like there's an exponent of 2, which makes this quadratic. Instead of writing an equation, because they already gave us an equation, they want us to put it in through the table. So here's all of our inputs. And they want us to plug them into that equation and see what it spits out. Here we go. 2 times something squared minus 3 times something plus 4. One at a time, I'm going to plug these into this equation, and I'm going to see what it spits out. I'm going to speed this up, though. Slow it down if you need to, or pause when you need it to. This function represents the area of a rectangle whose height is 3 more than twice its base. So we've got a rectangle with a height and a base. I know that the area is going to be height times base. So let's see what we put in for the values. The height is 3 more than twice the base. So 3 more means we're adding 3. Twice means we're multiplying the base. So the height is worth 2 times the base plus 3 more. So the area is height times, if we know it's height times base, and we're saying that this is our height, we're going to do 2b plus 3 times our base. I just took in what h was worth and I plugged it in. So when we multiply this, I'm going to rearrange things. Base times 2 base plus 3. If we distribute that in, we get 2 base squared plus 3b. So our equation we have that exponent of 2. which makes this quadratic. Oh, this one's fun. They told us a value of our equation. They know that -1 is 3. And this is a recursive function, so it's saying to get the next answer, you go to the previous answer, and then you're going to add 2. So if I want to know what's happened at 0, I got to go backwards. What was my previous answer? And add 2 to it. That would be 5. If I want to know my next answer, I go to the previous answer and add 2. So if I go back, 5 plus 2 gives me 7. Go back, 7 plus 2 is 9, plus 2 is 11. So it's adding 2 every time you move down. If it's adding 2 every time you move down, we know that that's going to be linear. Why? Because it has a constant rate of change. Miss Martin has mammoth sunflowers growing in her backyard, and recently her girls started tracking her growth, or their growth. It took a while for the seed to sprout. I wonder why it took a while for the seed to sprout. But since the girls have figured out that the sunflower plant is steadily growing 4 inches every week, that sounds like a rate, and that 6 weeks after the sunflowers were already planted, they were already 20 inches tall. Okay, let's start with this rate. Normally a rate is our slope, which is the change in y over the change in x. It's inches per week, so let's write that as a ratio. Inches per week. That tells me that my x is weeks and my y is inches. Let's make a table. X is weeks, and our y is inches. We also know that at the 6-week mark, after they were planted, they were 20 inches tall. So that tells us at 6 weeks, we have 20 inches. Or we have this coordinate, 6, 20. Write an equation in point-slope form to represent the situation. So what's point-slope form? Y minus y1 equals m times x minus x1. So we know a point. We have our x1 and y1. Then we need our slope. We have our slope. It was inches per week. What was the slope? 4 inches. And it's growing, so it's going to be positive. All right, let's put everything in. Y minus 20 equals 4 x minus 6. Using your model, determine how far underground the seeds were planted. So if you're imagining the ground, they didn't just put the seeds on top. They buried them and put them underneath the ground. So we want to know how far under the earth is that? So we're trying to figure out what that is. So when they planted it, they're telling us that we're going at the day they planted it, which was x equals 0 weeks. Okay, so let's use our model. We're going to solve for y. It's going to tell us how many inches underneath did they plant the seed. I'm just plugging x for 0, or 0 in for x. If I add 20 on both sides, yeah, I'll just do it over here. Got y equals -4, or y equals -4 inches. Is it okay that we had a negative answer? Well, it's underground, so we only measure positive above ground. So we would say how far underground? We would say 4 inches underground. There's our answer. How many weeks, so we're trying to find x, after the sunflowers were planted would they be 12 feet tall? Holy moly, we have a unit change. We've been talking about inches, not feet. So we need to know how many inches 12 feet is. Well, 1 foot is 12 inches. So if we have 12 feet, we'd have to multiply that by 12, right? 12 times 12 happens to be 144. So we're basically trying to figure out how many weeks after the sunflower was planted would they be 144 inches. So that's our y. We're going to plug it in for y. 144 minus 20, I'm using that equation, equals 4 times x minus 6. 144 minus 20 is 124. Distribute that in. 4x minus 24. I'm going to add 24 to both sides. I get 148 equals 4x. Divide by 4, divide by 4. That'll give me how many weeks? Let's see if we can figure this out. 148 divided by 4 is hard for my brain. So what I could do is bust it up into easier values. 120, 28. I know 4 goes into 120. Well, it goes into 12 3 times. So it goes into 120 30 times. Oops. 30 times. 4 goes into 28 7 times. So that tells me that this cut into 4 sections is 37. Okay. Help them figure out how tall the sunflowers will be at 12 weeks. Remember, weeks is x. So what does this mean? If y is 48 and we know that y is inches, we would say they will be 48 inches tall. Wow. We are going to solve these equations. Let's first by distribute. I'm going to make this 6 over 1 and 12 over 1 and multiply straight across. So 6 and 2 gives me 12. 3 and 1 gives me 3. 2 and 12 give me 24. 3 and 1 give me 3. Twelve divided by 3 is 4x. 24 divided by 3 is 8. 8 minus 4 is 4. And there's my answer for this first one. Let's do the next one. We are looking for values we can combine. 2x, x, and 3x. There's a 1 there. 2 plus 1 is 3, plus 3 is 6. Then I've got a negative 3 and a positive 1. Gives me minus 2. I'm going to add 2 to both sides. divide by 6 on both sides. And we get x equals 7. Use the given equation to fill in the table and answer the following questions. So I have this equation and I have all of these inputs. So I'm going to take turns plugging them into that equation and filling it out. I'm going to speed up the video, slow it down if you need to catch something. Okay, this is a typo. It should have just said f of 1 equals. So when the input is 1, what is the output? They didn't give me a 1, but they gave me a box for it, so I'll put a 1 right here. Got to plug that 1 into the equation. So we've got 1 squared plus 8 times 1 plus 15. 1 plus 8 plus 15. That's 9 plus 15 and gives me 24. So f of 1, 24. What about f of negative 6? We did have a negative 6, so we found out that one was 3 from right here. What happens when the output is 0? So you're looking through the outputs for anything that's 0. So I see a 0 here and a 0 here. So this has two inputs. It could have been negative 5 or negative 3. What happens when the output is 8? Looking through my outputs right here, it's negative 1, but this one had 2, so I wonder when there would be an 8 again. My pattern looks like it bounces off right there. Negative 1, 0, 3, 8. This one's probably 8 as well. Moving backwards, that would be negative 7. Okay, let's plot everything on our picture based off of these points. I'll start with negative 6, 3. All right. Our y-intercept is what happens at x equals 0. So when x equals 0, our y value was 15. Our x-intercepts is wherever the x hits 0. So here and here, which was x equals 0. No, when y equals 0. So is that negative 5 comma 0 and negative 3 comma 0. The vertex is where it bounces away. It's what we had right here. Negative 4 comma negative 1. Our axis of symmetry goes through the x-axis at our x value of the vertex. So we're going to say x equals negative 4. Domain for a parabola goes forever in both directions. So we're going to go negative infinity to positive infinity. We can't touch infinity, so they get parentheses. Our range has a lowest point at negative 1, but then it goes forever upward to positive infinity. And there's that. The rule for x and y-intercepts is that the opposite is going to be 0. So for a y-intercept, the x is going to be 0, and an x-intercept, the y is going to be 0. So I normally just divide my page into halves, and I solve for each. So if we ever see f of x, that's just a fancy y. So if I want to find the y-intercept, I'm going to say y equals 4 times 0 plus 6. Y equals 0 plus 6. Y equals 6. Let's do the next one. Instead of y equals, it'll be 0 equals 4x plus 6. I'm going to solve for it. Four does not go into negative 6, but I can simplify this into a negative 3 over 2, and I'm going to leave it as a fraction. like so. And we're just going to keep doing that. Y-intercept has an x value of 0. X-intercept has a y value of 0. Here we go. These don't simplify, but I can, they're not factorable, but 4 doesn't go into 18. So you can simplify this into a negative 9 over 2. Or if you wanted to write 4.5, that would have been fine. Oops, I did that in the wrong spot. Miss Thomas, what are you doing? That goes right here. Sorry about that. Now let's do this one. There we go. These two are a little bit harder, so let's take it a little bit slower. The y-intercept, we know x is 0. 0 squared minus 9 is 0 minus 9, or just negative 9. That part was easy. These ones, they've got 2 x-intercepts. So let's take it slow. It's going to be 0 equals x squared minus 9. Add 9 on both sides. To undo this, kind of like an opposite operation, we know that addition, subtraction are opposites, division and multiplication are opposites. If we have something to the power of 2, the opposite is to take the square root. What number times itself gives you 9? Hopefully you're thinking 3, but not just 3 gives you 9, but positive and negative 3 give you. Because if you think about it, 3 times 3 is 9, but negative 3 times negative 3 is also 9. So we have to include both of those. All right, let's do the next one. We're going to plug in 0 to find the y-intercept. If we plug in 0 for x, (32) take away 50 is negative 18. Now we're going to put in zeros for y. To times that quantity, I'm going to reverse it by doing the opposite and divide by 2. Before I can move this 4, it belongs to that squared exponent, so I'm going to do the opposite by doing the square root of both sides. That way we can get rid of that power of 2, and now it's just going to say x minus 4. The square root of 25 is 5, but not just 5, it's positive or minus 5. Now let's add 4 on both sides. So if we do 5 plus 4, we get 9. But if we do negative 5 plus 4, we get negative 1. And those are our answers. And that is the entire practice test. All right, hopefully we're ready for that test on Wednesday.